Okay, we're going to talk about factoring polynomials. And there are many things to be aware of when you factor polynomials. And I have given you a flowchart that describes the processes in order to factor binomials, trinomials, polynomials, etc. But in that flowchart, the very first step in factoring any problem is to take out the greatest common factor first. So greatest common factor, and from here on out I'll call that GCF. So greatest common factor. You know, after we do this, then we're going to go down in our flowchart and we're going to count the number of terms in the polynomial. And if there are 2 terms, we'll do one thing. If there are 3 terms, we'll do another. And if there are 4 terms, we'll do another. A little bit sloppy here. So we are at the top of the flowchart, and we are taking out the greatest common factor first. So actually, I've pulled a few problems together that are not on this handout, and I want to take you through some very simple problems. So 5x plus 25 is a binomial, but the number 5 can divide into both of those terms. So 5x could have 5 taken out of it. And if you did, when you distribute this, you'd need an x here, and you would need a plus 5 here, so that if you multiplied this back out, you would get this expression. So we have taken the greatest common factor out of 5x plus 25 and factored this expression. Here's another one. So 3x squared minus 6x plus 12. In this one, the common factor is the number 3. That's what divides into every one of these. So when I factor out the number 3, what I'll need in the front of this trinomial is an x squared, so that when I distribute this, I'll get that 3x squared. Next, I'm going to need a minus 2x, because 3 times a minus 2x is this minus 6x. And finally, I'm going to need a 3 and times a 4 here to get this 12 right here, and I am done. I've taken the greatest common factor out of this expression. What if there are letters and numbers? So what if I have 2x cubed minus 4x squared plus 16x? So what number goes into 2, 4, and 16? You want the greatest number, but 2 is a prime number, and that's the most that you can get out. If there is a letter common to every one of these, in this case x to the first, x to the second, x to the third, you will factor out the letter to the smallest power. The most you can get out of this one is this x. You can't get an x squared out of this one. So finally, you've got to decide what you're going to put here in the parentheses, so that when you take 2x and multiply it by something, you get 2x cubed. So it's going to be 2x squared, because I'm adding these exponents. So x to the first times x to the second is x to the third. In the next spot, I'm going to need a minus 2 on top of an x, because 2x times a minus 2x is a minus 4x squared. And finally, this 2x will have to be multiplied by a positive 8 in order for the 2x times 8 to give me the 16x. And I have finished taking the greatest common factor out. It doesn't mean that I'm always done, but it is always the first step. So we have a couple more problems to do. I'm going to go ahead and finish these. So the greatest common factor here is a 5. And then the only letter that's common in both is a, and it's a to the first power. So I'm going to factor out a 5a. In order to get this, I'm going to need an a here, so that 5a times a will give me 5a squared. I need a minus 4x here, so that 5a times a minus 4x will give me a minus 20ax. And I'm all done. My answer is handwritten in black here. A 4, a 14, and a 16. They're all even, so it's probably a 2, because it can't be a 4, because 4 doesn't go into 14. Are there p's in everyone? P to the third, p to the fourth, p to the second. You can only factor out the smallest exponent. Are there q's? Yes. Q, q squared, q to the third. Q to the first is the smallest exponent. Now you go ahead and decide what needs to go here so that when you multiply this times that, you'll get what you started with. So this 2 needs to be multiplied by a 2 to get the 4. P squared needs to be multiplied by p to the first to get p to the third, and this q is covered. Next term, I need 2 times a minus 7 to get the minus 14. P squared has got to be multiplied by p squared, so that 2 plus 2 is 4. This q has to be multiplied by q to get q squared. Finally, the last term, 2 has got to be multiplied by a minus 8 to get the minus 16. I've got the p squared covered. I've got a q to the first, and I need this to be q to the third, so I'm going to use q to the second there. And if I distributed all 3 of those, I'd get what I started out with, but this is my answer. I've taken the greatest common factor out. Let's see. This one, 4, 10, and 5. 5's a prime number. 5 and 4 don't have any common factors, so there is no number that you can take out of all of these. But there is a common letter, and that's the letter y. So that's all I get to take out of these. So the first term will have to be a 4x squared, so that the y times 4x squared is the 4x squared y. I will need a 10x here, so that when I multiply that y by y, I get 10xy. And then I'll need a 5 here. It's possible later that this will factor. I'm not even sure. I haven't even thought about it. But I have taken the greatest common factor of y out. Same problem twice. So let's ignore that. Would you now pause this video, and I have given you some riddles to work on. And there's a riddle that's got a page number in the bottom right corner. It's called page 81. And the title of the riddle is called Double Cross. Would you take a moment to do your homework, which is to finish this riddle? And the whole idea in this whole riddle is to take a monomial, greatest common factor, out of each of those polynomials. Do that, and then we'll move on.